Hello, welcome to the Maths Times Tables talk. Just going to go through how we're approaching times tables at St James from this year. We're starting to go back to use number sticks to help children to learn their times tables. And the idea of this is that the children build up a visual representation of what the times tables look like. So for example, if we just use this number stick to count to 10, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if we kind of build up going into times tables, the children would teach the children that this first bar would represent 2, this end bar would represent 20, and then the halfway point would represent 10. So we're trying to kind of build up that visual image for the children so they understand what the times tables can look like visually. And what we are using is something called a number link board. Okay, so a number link board will enable the children to write their times tables out, and then kind of as they go through the key stages begin to make relationships between decimals and kind of using them to work out bigger numbers as well. So in this example on the board, the multiplicand, which is 8, so it's the 8 times tables, has been used when applied to counting in 0.8. So the children can then begin to see the pattern and the relationship between 4 times 8 being 32 and 4 times 0.8 being 3.2. So this is what a number link board looks like. So it works kind of similar to the counting stick in the fact that we have different colours. We've got the 10 bars at the top like a counting stick would have, and then the halfway point. And again, the idea for this is that if the children are doing their 8 times tables, if they were asked 7 lots of 8, which would be here, they don't need to keep starting at 1 lot of 8. They can kind of, if they know that 5 lots of 8 is 40, then they can count on from there. And the reason why we don't write the multipliers at the top is because we want the children to become understand visually what the numbers represent and where they are. So for example, we don't need to write 1 lot there because the children will know that that is the first number in the times table. And likewise at the end, that's the 10th number. So we don't need to write times 10 at the top, but this is just an example that we would show the children so that they can begin to understand what each of the boxes represents and how many lots of that times table there are. Okay, so how we do it is we go through the facts that the children will know first. So they, after writing the multiplicand in, which in this case, as I said, is the 8 times table, they would start off with 1 times 8, then do 10 times 8. And then from there, they can use their doubles and halving knowledge to go through to apply it to the rest of the times table. So half of 10 is 5, so that's halfway through. So half of 80 would be 40. So we kind of use a little phrase, 1, 10, 5, and then derive. So we can derive facts from what we have already. So the way we would do that is that if you've got 1 lot of 8, which is 8, if you double it, you can get to 16. And then from there, you can double 16 to get 4 lots. And then if you double the 4 lots, you can get 8 lots. So from there, you can begin to kind of fill in the times tables and begin to understand the relationship using doubles and halves. When you're coming on to do, so if I just write that in now, what I would do. So if I did double 8 being 16, and then I could use 2 lots of 8 is 16. So if I doubled that, I'd get to 4 lots, which would be 32, and then I could do the same again, so double 4 lots would be 8 lots, which would be 64. So I can begin to fill in the different numbers from there. So where to go from here? We know that this lot is 5 lots, so 6 lots would be 5 lots plus 1 lot, which would be 48. The 9 lots you can do by counting back, so if you've got 80, take away 1 lot, which would be 72, and then the 3 lots you could do by halving the 6 lots, so half of 48 is 24, which would then just leave you 1 number to do. So you can either do 48, add 1 lot, You could do 64, take away 1 lot. You could do 5 lots, add 2 lots, which is probably the easiest one to do, bearing about considering the numbers that are involved. So it would be 40 plus the 16, which would be 56. Okay, so that's the general idea of what we would do. When we're going into 11 and 12 lots of the number, we'd then use these 2 boxes here. Okay, so just move these off the board. So this is just the example that I've just been through, but they didn't go through kind of the stages that we went through then, how to work it out. So this just basically explains that you can get 8 lots by doing 5 lots plus 3 lots. So there's different kind of variations that you can use to do it. And this board can also be used for multiplication in Key Stage 1. So for example, drawing visuals, so the use of arrays here. So the children having kind of groups of 3, if they've got 3 groups of 3, how many have they got altogether? So we're kind of bringing in and recapping the visual element of it as well. And also you kind of applying it with physical apparatus, so linking this to money, so having groups, so the children can do it using concrete apparatus, they can represent it visually, and then it kind of can help them build on to use their abstract as well. So just going to go through a few examples, like I've said before, about how this can be applied as the children go through Key Stage 2. So writing the 7 times tables at the top will help apply this to knowing their, or not knowing their 0.7 times tables, but they can apply it to the fact that 7 times 5 would be 35, so 7 lots of 5 lots of 0.7 would be 3.5, and beginning to see the relationship between those numbers. The other advantage of this board is if the children were having to do lots of 79, then they can kind of use a little bit of rounding skills to help them. So if they know their 8 times tables, this can then be applied to counting in 80s. But if the objective was to actually count in 79s, then they can use this board to help them. So having the 80s above them, and then the children will think, right, well 1 lot would be 79, which is 1 less than 80. 2 lots is 2 less. 3 lots is 3 less. So actually the accuracy of counting in 79s will be there because the children are just subtracting 1 number each time as they're going along the board. Okay, so the board can also be used to division as well. So like we kind of touched upon before about the using arrays as 3 lots of 3, it can also be kind of talked about as three groups as well. So kind of if we've got 9 and we had to share them out between 3, how many would they have each? So it can be used for division too. Another example of some division. Going on to remainders, how many do you have left? So this could be kind of, you could have 13 divided by 3, how many would you have? You'd have 4 equal groups and you'd have 1 left over. So the children can represent this using colours, they can represent this visually to see that actually how many do you have remaining. And this can be done as a little investigation. So how many could you have that is 1 more than a multiple of 3? So there'd be different options as kind of an open-ended question to ask the children. Going through the school, this number link board can help in lots of different ways as well. So the reason why we do the number facts in the school is, questions like this, 640 divided by 8, we would expect the children to be able to, if they're fluent in their times tables, to be able to do this without using a method. So understanding that 64 divided by 8 would be 8, and then 640 divided by 8 then would be 80. So it's kind of building up that relationship and getting the children to understand and recognise patterns between the numbers. Can also be powerful when helping to solve fractions and kind of grouping. So if we would find 1/8 of 480, we'd do 480 divided by 8, but this number link board can help us to work that out as well. It's also good for estimation. So if you were asked, well, what is 3 lots of 58, if you round that number to the nearest 10, then if you know that 3 lots of 60 would be 180, and the questions we'd ask the children were, well, if you had 3 lots of 58, would your answer be more or less than 180? and then we can get some good discussion about, well, you've rounded up each time, so the answer would be around 180, but it'll be less because you've rounded up 3 times. Same with decimals, so if they were doing 4 lots of 3.7, if you rounded that number to the nearest whole number, 4 lots of 4 is 16, so the children will begin to understand that, okay, our answer is going to be around 16. We've rounded up each time, so the answer is going to be just less than 6, or slightly less than 16, but around about that. And this kind of enables the children to understand if they've got an answer that would be in the hundreds here that they might have miscalculated. So the other thing is, as we're teaching the times tables, patterns and links and relationships that we can make. So in year 2, if the children learn their 2 times tables, when they start year 3, they learn their 4 times tables, and they can make links between the 2s and the 4 times tables, just like the 6s and the 12s do here. 6 is half of 12, so then all the numbers as they go along will kind of correlate in that pattern. So alongside the number link board, as mentioned before, we can use, in this case, we can use the Deans to represent visual images. So the children are continuously understanding what the numbers can look like visually, and can use it to help like those kinesthetic learners to help actually manipulate the concrete objects, as well as showing them visually with this number board in place. So it can also be used to apply to word problems as well. So each ticket from London to Middlesbrough costs £116. How can we find the cost of 6 tickets? So you're doing 6 lots of £116, which can be used using the number link board. And then the problem can develop as well. So if we look at this, so working out 5 lots of, 1 lot of 116, you could work out 10 lots and then 5 lots. To work out 5 lots of £116, and then if you add the 5 lots and the 1 lot together, you get £116. £696. But then if the question asked you, well, what would happen to the price of the tickets if each ticket was reduced by £2? So using this board, if you reduced each by £2, then what would happen to the numbers? So that would be kind of a discussion we could have with the class. And they could then see the pattern that would kind of occur if each price got reduced to £2 per ticket. So these are just some of the questions that might arise, and how we would need to use the times tables to fluently in each year group. So this is in year 3, so 2 times 45, and the children would have to understand that 45 can partition into 4 tens, which is 40, and a group of 5. So 2 lots of 4 would be 8. So then using that knowledge, 2 lots of 4 is 8, 2 lots of 40 would be 80, and then 2 lots of 5 is 10, and then combine them together to get 90. So it's this type of fluency that we want built up for the children when they're learning their mental maths and their times tables. So in year 3, all of these times tables can be applied in context in worded problems as well. So a lot of the times table, this doesn't require the children to kind of use formal methods. This is just all kind of mental calculations, that there's more than one step that they have to follow, but actually a lot of the calculation they can do mentally, as opposed to using formal methods. So again, going on to like a year 4 objective, so it's fluency in times tables and knowing that 9 times 11 would be 99, so using this information to work out inverse questions as well. Year 5, so times tables will help with fractions. So in this example, 5/7 plus 3 over 21. The children have to find their common denominator, and to do this, if they're fluent in their times tables, they'll find the common denominator to make them the same, so that they can then add the fractions accordingly. So we do teach the formal methods as well, so it's not like we just want the children to be fluent in their times tables. We do kind of expanded method of multiplication before they do short multiplication and then long multiplication in year 6. So the children will be taught the formal methods, But again, if they're fluent in their understanding of the times tables, it makes that process easier. Okay, and then when we're going into year 6, so calculating percentages of numbers, again, it's all linked to times tables and the knowledge and understanding of the times tables, and being fluent between multiplication and division, and having that understanding what the numbers represent and how they can be represented. And likewise, just here's a worded problem that involves multiplication that can be done without the use of formal methods. It can just be kind of mental calculations, but if the children are fluent in them. So what we're doing at school at the moment, we are doing a times tables challenge once a week. So times tables are taught during lessons, and the children have a challenge once a week that is catered for their needs. So in year 2, the children will be starting off on 2s, 5s and 10s. When they move into year 3, they will start their 4 times tables, but those children that are still working on their 2s, 5s and 10s will do so. And the scheme runs through, so by the end of year 4, the children should be fluent in their times tables up to 12. Thank you for listening.